Deep within the cosmos lies an object so dense that its gravity swallows entire stars and prevents even light from its grasp. These absolute voids have driven a century of scientific obsession, challenging everyone from Albert Einstein to the astrophysicists of the modern era. They exist across a staggering scale, from primordial holes the size of an atom with the mass of a mountain to supermassive giants containing millions of times the mass of our Sun. Almost every galaxy orbits one of these supermassive giants. Our Milky Way is anchored by a 4 million solar mass black hole known as Sagittarius A star. Because these giants dictate the rotation and structure of entire galaxies, they are recognized as the ubiquitous gravitational killers of the universe itself. Our Sun will eventually shrink into a dense white dwarf at the end of its 10 billion-year life. It lacks the mass required to collapse into a black hole. Black hole formation is reserved for stars at least 20 times more massive than our Sun. When these massive stars exhaust their nuclear fuel, the core collapses under its own immense weight, triggering a violent explosion called a supernova. As the outer layers blast away, the remaining core continues to compress inward, concentrating its mass until it forms a single point of inescapable gravity. The most destructive entities in existence are born directly from the violent collapse of the universe's most brilliant stars. An inbound journey toward a black hole reveals a chaotic storm of matter rather than a simple, silent void. This is the accretion disk, a violent, high-speed ring of gas and pulverized stars trapped in orbit around the dark center. Internal friction creates temperatures exceeding 1 million degrees, blasting high-energy X-rays into surrounding space. This structure moved from mathematical theory to reality in 2019, when the Event Horizon Telescope team captured the first visual evidence of a black hole. This historic image shows the glowing accretion disk surrounding the central void, providing the first direct look at the light being warped around the hole. Since the hole itself consumes all light, observing this ring of destruction is the only way we can perceive its presence. Beyond the disk, we enter the territory where Albert Einstein's theory of relativity dictates a new set of rules for reality. This is gravitational time dilation. The black hole's mass stretches space-time so severely that it slows down time for anyone near it. Because of this warping effect, a single hour near a black hole equals 7 years on Earth. Closer still, we reach the photon sphere, a delicate ring where gravity is so strong that even light particles are forced into a permanent circular orbit. The gravity here is so absolute that it shatters our standard experience of time and space. Crossing the event horizon marks the transition into the absolute dark. At this boundary, the pull of gravity officially exceeds the speed of light. Any object crossing this line faces a fatal tidal force, as the gravity pulling on its leading edge is exponentially stronger than the pull on its trailing edge. This is spaghettification, a process where the victim's body is stretched into a thin, elongated strand like rubber. The stretching continues until the object is completely shredded into its component atoms. The event horizon is the ultimate point of no return, a threshold that leads to total deletion from the observable universe. The final destination for all captured matter is the singularity, located at the black hole's absolute center. This is a point of infinite density, where an incredible amount of mass is crushed into a space smaller than an atom. Science fiction often envisions these centers as portals to other dimensions, but the scientific reality is likely far more destructive. Within the singularity, the fabric of space-time is so mangled that every known law of physics and mathematical equation completely breaks down. We have successfully photographed the glowing edges of these cosmic giants, yet what happens within the singularity itself remains the universe's most terrifying